is a pan-institutional program. So as I mentioned, Smithsonian has I always forget the numbers. I think it's 9 museums and 32 research centers. It's some amazing number of research and science centers around the world. Obviously, most of us are clustered around the DC area, but my role is really in bringing some unity and some strategy to the work that is happening around our efforts to understand how and why animals move across changing landscapes and seascapes. So I'll talk a little bit more about that now. So I always like to start off with just a little overview of why do we care about movement? And the main reason is that movement arguably underpins the persistence of life on Earth. It connects disparate ecosystems. It drives key biological processes like migration, mate finding, and nutrient cycling. And it underpins healthy communities of people and wildlife. However, the impact of global change on the movement of species is still poorly understood. And that is kind of the core of our mission at Movement of Life, is to really understand how people are impacting the movement of species and how we can work with communities to preserve the ability of species to migrate and move in general. So we are a community, as I mentioned earlier, we're a community of practice that spans multiple Smithsonian research units and museums. And we're really motivated by the Smithsonian mission of the increase and diffusion of knowledge. And for us, diffusion includes not just publishing research, but contributing to education, training, and conservation. This is a snapshot of our core leadership team. Our broader team includes tens of postdocs, interns, other graduate research fellows, as well as hundreds of in-country partners. Most of our work is, and I wanted to point out Matt Ogburn down here in the lower left, who I think you guys heard from maybe this year earlier, or maybe year before, yeah, about eDNA, and he's based at the Environmental Research Center in Maryland. He leads the fisheries conservation program for Movement of Life. Most of our work is international, although we do have a few projects in the US. The international focus is really driven by our connection with the National Zoo. So we work in landscapes with where species, we aren't limited to the species at the zoo, but we are kind of the field side of some of the species that are housed at the zoo. So I'm going to talk about some of those projects, specifically reintroduction efforts for these animals into the wild. But Matt Ogburn leads a lot of our North American work, and it is just out your back door in Maryland. So and then we have another kind of cluster of research sites in Montana at the American Prairie Reserve. Also, because you guys are interested in natural history, I'm also interested in just the history of science, and working at a place like Smithsonian, we really have a luxury of being able to dig into this. And the history of animal tracking has just really captured my imagination. This is really just a side project I've been digging into since I've started, and learning I think there's something so interesting about our fascination with where animals go, being able to spy on animals, and how we do it has really evolved over the years, but it still always involves a lot of kind of duct tape and PVC pipe efforts. So even though it's high tech at the same time. there's just a few stories I wanted to highlight tonight. First is Paul Barch, who was a mollusk researcher at the National Museum of Natural History. And you might not think of mollusks as being a group of animals to really track, at least not at first. But he was really interested in whether birds were moving populations of mollusks between bodies of water. And so he started the first bird banding study in North America actually at the National Zoo on a population of black-crowned night herons that is still roosts at the zoo today. You can still go see them. And we still have science happening on that colony of birds, tracking science happening with that colony of birds. So he first used metal bands to mark the herons in 1902, and he inscribed each of his bands with a number and a message that said "Return to Smithsonian Institution." And then over on the right is Tuck Hines, who, if you visited CERC, maybe some of you met. He's the current director of CERC in Edgewater, Maryland, the Smithsonian Environmental Research Center. But he got his start with tracking blue crabs in the Chesapeake Bay using ultrasonic telemetry. And he was the first person to use this technology to track blue crabs in the Chesapeake Bay. And then the middle is one of my favorite stories, and I'll direct you guys to some more. Her story has gotten more attention in recent years, and so there are a few places to go do deeper dive, but this is Monique the space elk. She was the first GPS collared animal in the world, and she was collared in I'm pretty sure it was in Wyoming in the 1960s. And you probably notice off the bat that collar is fairly monstrous. And that's because it was a repurposed ocean buoy. So the ocean buoys had GPS tracking technology already built in, and I guess this was the smallest they could make it at the time. And she really caused a stir, a kind of in both igniting people's interest in the sort of what this new technological advance might mean for conservation, for our ability to preserve animals, but also opening up ethical questions about, if we're going to be tracking animals, how can we do this humanely, responsibly, and in a way that's worthwhile? So the Smithsonian this was a collaborative project between the Smithsonian, the National Park Service, NASA, several other organizations. And I think the Smithsonian role in it was to actually designing the collar. So it was an engineer I think also at the Natural History Museum that designed her collar. So there's some interesting, I've been digging into the archives too, just to get some of the public responses to her collaring. And it was a mix. It was like some excited letters, some very concerned letters. I think what Monique really brought to the animal tracking world was, a demonstration that this is possible. She unfortunately was shot by a hunter not long after she was collared. The hunter apparently said he did not see her collar, which is hard to believe. He said she was behind a tree. But so there's more to this story too. And if you are interested, that we did a podcast with the National Air and Space Museum where we kind of delve into the history of Monique and explore some of these themes of technology and animal tracking and ethics as well. So one thing I do want to point out before we do them is Monique's collar, though it was large, it collected something like 1.8 a day, I forget, or 2 points a day. It was very infrequent. It was still better than no information, but that's kind of where we're starting at. Big technology with maybe 1 point a day, even, and can only study the largest animals, really. Today, we have rapid advances in the technology that are allowing us to track things as small as insects, many migratory birds. And this is a short video from MoveBank, which is the largest repository of animal tracking data in the world. And it's showing the movement of storks from Europe into the wildebeest migration in Kenya and Tanzania, and then how they move along to South Africa and are flying through other tracked communities of Cape Buffalo and finally elephants before they then return back to Europe. So I think this animation really captures another element of what excites me about animal tracking, that it really reveals these invisible connections in our world, and can really be a tool for connecting communities to both their landscapes and landscapes that are farther afield. So with these themes in mind, our approach at Movement of Life is we conduct some basic and applied research to just obtain new insights on what is driving the movement decisions of animals. We work closely with stakeholders to make sure all of the information being collected is actually will be useful to people. And we are committed to training the next generation of ecologists. So some of our key questions that we can ask with this technology is, how much space do animals, basic things that inform, protected area design, resource management on multiple scales, the design of smart infrastructure, where we should place wildlife crossings, that sort of thing. And also just understanding what is driving the loss of populations, because it's very difficult to actually track individuals from birth to death any other way. So these are some of the connecting questions across our research units are: how much space do animals need to survive? How do anthropogenic barriers influence access to critical resources? And then what methodological advancements are needed to answer these questions for most species? As I mentioned earlier, we also have a large emphasis on reintroductions. So there's many we could talk about. One is the Guam kingfisher being reintroduced to Palmyra Atoll on the left here, and then the scimitar horned oryx in Chad is a story I'd like to spend a little more time on, because it's a very optimistic story and just impressive, and sort of demonstrates the value of animal tracking to this type of work. So these are, but before their reintroduction in 2016, the scimitar horned oryx were extinct in the wild. So they only existed in private collections or zoos. And through reintroduction efforts since 2016, there are now over 500 free roaming individuals, and most have been fitted with GPS tracking devices that help us monitor the health and survival of this threatened species. So this is a video. This is an kind of remarkable study in the number of animals that are tagged at one time. And this is because it's so important to follow these animals once they're released, to understand, because there were no wild populations to compare to. There's a lot of interest in what threats they might face, and then how they are surviving, and so that we can assist with management if needed along the way. And so this is a calf in the field that would really, there's no other way to know if an animal is born unless we can track its mother. So this is, I'm just going to walk you through the process of this. Once an animal is, the mothers are closely monitored for their reproductive signs of labor, I guess, signs of birth. And when they are pretty sure that there's a calf, the field team will go in and retrieve the calf. The field assistant is being very careful right now because the mother is nearby and very protective. And you're going to see him grab the calf really quick in the bush. And they take it into the vehicle because mama is not happy for a little bit. And that is where they do about a 5-minute health exam. They apply an ear tag, which is, again, the only way that we can know if this calf makes it to adulthood. And then they take a non-invasive DNA swab. And then within 5 minutes, the animal is reunited with its mother. So just a few project stats. There's been over 285 scimitar horned oryx reintroduced to date, with over 500 calves born in the wild and really high or relatively high calf survival rates, over 80%, which has led to over 500 free-ranging oryx today. And I just want to highlight that no project like this is done by one organization. It's a huge collaborative effort between the government of Chad and the Environment Agency Abu Dhabi. And under the leadership of the Environment Agency Abu Dhabi, on-the-ground implementation is carried out by Sahara Conservation with technical support provided by the National Zoo and Conservation Biology Institute, Zoological Society of London, and other partners. If you'd like to learn more, this QR code will direct you to the project page of Sahara Conservation. And one very tangible highlight is that the scimitar horned oryx was downlisted last year from extinct in the wild to endangered by the IUCN because of this progress. If you are excited about oryx, you can visit them in Front Royal. So at the Conservation Discovery Day, we have the captive population, and you can now experience this field project on large scale video format at the National Museum of Natural History. This exhibit just opened about a month ago. It's going to be open, I think, for several years. It should be there for a while. So, and it's a collaboration with NASA and Smithsonian, and there's about a 7-minute film that walks through the story of the oryx reintroduction. So I couldn't get a high quality photo with the oryx story in there, but if you're interested, this QR code will also take you to the website. So following up on our scientific focus is making sure this science is being used by stakeholders. So there are a number of examples of this to share, but I wanted to pull out a couple really locally driven ones. So the Atlantic Cooperative Telemetry Network is really, it's a national network along the Atlantic coast of telemetry receivers. So because GPS satellites cannot communicate underwater, most aquatic tracking happens using acoustic devices. And until very recently, like even a couple years ago, the only way that a researcher who has a tagged animal might know if their animal it was picked up by a receiving station is to actually like physically email a Excel file of all of the tags that were picked up by the receivers. So usually universities or government agencies manage these receivers, and there was this whole network for exchanging information about who was picked up where. And then about every 3 months or so, they would do a big update and figure out where all the animals have traveled. That's basically still what happens today, but it is more automated. And the Smithsonian, so Matt Ogburn's group at CERC is the lead of this effort. There's also the Shorebird Science and Conservation Collective, which is based at the National Zoo, led by Autumn Lynn Harrison. And they are amassing one of the largest collections of shorebird tracking data, and working with federal agencies to run movement analyses. So animal movement data is pretty technical to work with. And so it's not always accessible for government agencies and conservancy managers to do their own analyses. But this is a service that's provided by the Shorebird Science and Conservation Collective, and that data is being used to inform where wind farms might be placed, how oil development is impacting the movement of animals, many cool applications there. This is the Migratory Connectivity Project, which is another kind of large-scale tracking initiative, global in scale, for long-distance migratory birds. It's collected over 7 million bird locations using electronic tracking devices since 2014. This project is also based at the National Zoo, led by Autumn Lynn Harrison. And most of this research centers on knowledge gaps. So where are the important places for animals? How are they connected? When or where are animals dying? And how is their movement limited? How are humans affecting these patterns? And it's really these questions focused on conservation that motivate the work. So a few more examples from marine and terrestrial realms, I guess, at the Smithsonian Tropical Research Institute in Panama. That this image on the lower left is a shipping lane in blue, and the small orange dots are blue, or I guess it's multiple species of whales, but or it's humpback whales, sorry, it's humpback whales sightings. And so scientists at the Tropical Research Institute are using these observations to advise on when shipping traffic should be allowed in or not, to reduce the chance of ship strikes. There's also work in Myanmar with Asian elephants to reduce the risk of, or to manage poaching impacts on Asian elephants. We also have a very strong quantitative or an analytical group at Smithsonian. So there's also just some of this basic science focused on advancing the field of movement ecology. This includes testing new technologies and attachment techniques that are less invasive, and integrating animal movement data with remotely sensed data, so data that comes from satellites, to understand how the landscape is affecting the movement decisions of animals. And so through training programs, we transfer this knowledge to others. So each Smithsonian unit has their own internship, fellowship training programs, but some of the larger ones are the Smithsonian Mason School for Conservation, which has a physical campus. So it's a collaboration with George Mason University. There's a physical campus at the Front Royal campus, where undergraduates interested in conservation science come for semester-long courses. There's staff housed there, the students are housed there, and they take classes, and then they're embedded in internship programs with Smithsonian scientists. There's Animove is one of our training courses for animal movement. It's one of the few training courses out there to get like graduate level researchers trained up in using animal movement data. And then we often give guest lectures. We have internship at undergraduate and graduate level that are often long-term. And then fellowship. Our fellowship program is really, I think, the heart of what we do. We can't do anything without our fellows. So both postgraduate and graduate fellowships. And those are really managed through university partnerships. The other exciting part of getting to do this job at Smithsonian is just the outlet we have for education and outreach. We work with the National Zoo, with the Air and Space Museum, the Natural History Museum on all kinds of outreach programs. These are just some digital programs that I should have put a QR code to, so we can, if I can share this after, but the Women on the Move series highlights women in science at Smithsonian that study animal movement. The new birdhouse at the National Zoo features is completely dedicated to the movement of animals, birds. And then the One World Connected exhibit at the Air and Space Museum opened a year or two ago now, and features animal tracking technology as part of the physical exhibit space, as well as animal tracking data in the Science on a Sphere exhibit. There's also the Side Door podcast. If you guys are not familiar, I highly recommend. This is Smithsonian's podcast arm. It's just behind the scenes looks at anything across Smithsonian. So they often, do deep dives on museum objects or just interesting stories of the history of people at Smithsonian. And these graphics are from stories that have been done on the animal tracking work across Smithsonian. So I can share those after as well. So how is the field changing? There's a big focus on miniaturization. So the battery power needed to transmit data from an animal on Earth to a satellite in space is a lot. So the battery limitation has always been a problem as far as a limitation on how small the devices can get. But there's a lot of interesting creative solutions to this, including putting an antenna on the International Space Station that's dedicated to animal tracking. So because the International Space Station is in lower orbit, the energy needed to transmit data is lower. So you can have smaller tracking devices. This project is called the Icarus Project. It's led by the Max Planck Institute, and really exciting space to watch. There's also lots of movement in open tag development. So historically, a lot of our tracking devices are developed by a few large manufacturers, but with there's really there's no reason that they can't be developed in-house. So there's so much happening in that space. I don't know how to summarize it, but that's an area to lower the cost of tags. There's also new sensors coming on board. So there's a lot of interest in using animals as environmental sensors for areas that are not really accessible to humans, or even gliders or things like that in the ocean. So I'll talk about a little bit more about that on the next slide, but and then just improved accuracy is always helpful. And so with these advances, animal tracking is really becoming more and more relevant to our daily lives. For example, like I was saying just a second ago, these animal-borne sensors are actually feeding high-resolution environmental data into global climate models now. So this is an active data link between animals and climate scientists that I think is so cool. They can sense anomalies in the ocean that might indicate hurricanes, or I'm not even sure what the whole scope of this is, but there is conflict mitigation, like the example I shared from the Tropical Research Institute, where tagged whales are helping ships avoid whale strikes. One of my favorites is that the behavior of goats can indicate an earthquake reliably. And you can detect this with really fine scale movements of the animals. So there's some experimental studies where they're trying to see if goats might be provide an early warning system for earthquakes. There is also links to global health. So both in tracing the movement of pathogens between species and actually remotely detecting diseased animals. So just by looking at the ear flick, I think it was pigs, the ear flicks of pigs, there is a close relationship with disease status. And I'm working on a project right now where we're looking at just the spacing of individuals. We're looking at Cape Buffalo in South Africa. They place themselves differently. They have unique spacing when when the herd is infected with tuberculosis than when it doesn't. So all really interesting frontier there. And then maybe a more recognized use of animal tracking data is informing the placement of crossing structures for green infrastructure. I just wanted to mention this as well, as this another kind of frontier of animal tracking work, is to actually move away from tags entirely by using drones and even satellites to track the movement of animals in the field. The application of this is, I think, it's limited to areas that are open, that have large aggregations of animals, but at the same time, the possibility to understand something about how animal groups are navigating the landscape, especially as these landscapes are changing so rapidly, is really exciting to me. This is a quick illustration of a project that I've been working on since my PhD. We recently published it in Nature Communications to detect the largest, it's the largest detection of an ungulate group from space. So this is high resolution satellite imagery. It's 30 to 50 centimeter satellite imagery. Each little red dot is a wildebeest in the Masai Mara National Reserve. We detected over 500,000 wildebeest, and this ability to observe animal groups at really unprecedented spatial scales is also a new frontier for both behavior and just basic movement ecology. Finally, my most recent work has been focused on bringing the work that we've been doing with communities at a park or regional level and scaling it up to the global level. The biodiversity community has kind of lagged behind the climate community in our ability to organize at a global scale for global conservation of biodiversity. So, but a lot is happening in this space in the last decade, really. And the movement community has arguably lagged behind that. So we're just getting organized ourselves, but we have all of the components needed to really inform a global network, a global observation network for animal movement. We have globally distributed observation, globally distributed research networks that are already used to collaborating and sharing data. We have advanced technologies and then many applications of interest to global biodiversity conservation. So we are forming a new community of practice to help make I guess, get these changes into reality. So with that, I'm happy to answer questions and just really appreciate your time and would love to hear from you guys.
Thank you, Lacey. If you can unshare, we'll put the spotlight back on you. And now we'll open up the floor for questions. If you would like to ask a question, you can raise your hand and you can unmute and when you get called on, or you can put it into the chat box here. And I missed it. We did have the folks from the Mid-Atlantic Data Portal. Are y'all working with them?
It's possible that, but I may not be aware of it. Matt
Yeah,
would know.
Yeah, so they were doing all that. This is fascinating technology and what we're learning from this. In the scimitar one, has there been, is this groundbreaking, or has there been other places where it's been extinct in the wild and the populations are being brought back, or was this a first of its kind?
That's a good question that I also couldn't answer definitively. But I think in general for an ungulate, it is definitely rare, unusual, just because the effort. Well, it's rare that a population of ungulates that is extinct in the wild would exist in a collection, in a collection that would be large enough to repopulate a wild population, and just the effort to do it is also tremendous. So I can say it's rare. It's probably not the only case, but it's definitely, yeah, a big achievement.
Do you know what was the cause of the extinction? Was it?
Yeah, I think hunting is a big part of it, and habitat loss as well. There's a lot of competition with cattle for ungulates really around the world, native ungulates around the world. The usual players.
I didn't know if it had something specific to the shape of the horns or anything like that. I didn't know, because it's such an unusual.
Yeah, that's a great question. I don't know. Yeah, I think the name just comes from the horns look like scimitar horns.
All right. So Richard asked, is this information available to other governments and groups that may use it for planning policy purposes? Is the information free? Could a regular person like us get access to the things we've been showing?
So do you mean the tracking data, maybe?
I think he means the tracking data. Okay,
yeah. So it's a great question. It depends is the short answer. So data, video. So there's definitely lots of, I'd say most data, if it's a federally funded project, which all of this work needs to be made publicly available at some point. There's often an embargo on it for research purposes, and in many cases, because the species we're working with are rare and endangered, the tracking data may never be released publicly, but we strive to at least document that the data exists in repositories like MoveBank, where anyone that is interested, you can go search. I'll put a link to MoveBank in the chat. That would be my first place to go to if you are interested, to see what's there. And there's at least, it'll say like scimitar horned, I actually need to check if the works are in there, but that the project was done, and then it'll have a contact point for that data set. Then yeah, the videos and reports and all of that, everything is free and made. I'd say as long as the publications are sometimes behind paywalls, but also federal research is often required to be made freely available. So this should be a small barrier for a lot of these projects, as long as there isn't a like sensitivity reason to not release the data. But if anyone has specific interests, definitely reach out.
Kathleen asked, did the ungulates migrate? I guess the ones that were in.
The oryx, maybe. So we were actually just talking about this today, that we don't know. So we don't know historically. There is reason to think that they would, because they're in a very arid system that's seasonally wet. So they are starting to show some like potentially migratory movements, but they aren't technically considered migratory yet because it's not consistent. But there's other studies that have shown, it's kind of cool that migration is culturally transmitted. So this is from bighorn sheep. So when you lose that cultural knowledge, as you would with a population that's extinct in the wild, it takes time to it can come back, but it takes time to rebuild that. And that's also something we're looking at with the oryx, why we have so many of them tagged. We can start to look at things like social transmission of information and behaviors.
So you're saying that the sheep teach the oryx how to migrate?
Sorry, that's merging two stories. The sheep are an example of a population that was reduced to a point that the cultural knowledge of migration was lost, the bighorn sheep. But over time, as the population recovered, that knowledge became they were able to regain it, but I think it took like a decade or something like that. So sort of like these lagged effects like that we have to be aware of when we lose a species, and if we are able to bring it back. Just because it's back on the landscape doesn't mean that it's actually that they're functioning as they did historically. Yeah.
Wow, so they have to relearn how to migrate. Is that what you're saying?
At least in the bighorn sheep scenario. So, and I think there are others.
I had a question about the technology. Is it that is the science driving the technology, or does the technology drive the scientific questions on that? So does the scientist say, I'm studying this and I need this thing, to answer that, and then the research people come here and make it?
Yeah, I think so. Arguably in the beginning, the technology drove the science. I mean, I guess it was a bit of both. Like they put a collar on the elk because someone wanted to know where it went. But at the same time, there was, we didn't know what we could do with it. So I think it's this like, ideally it's a feedback loop. Today, I think it is still that feedback loop. And organizations like NASA in particular are actively taking a role in defining that technology at kind of on a national level. So there is a lot of communication between the scientists and NASA engineers about what the needs are for animal tracking and how that can be built into like NASA's missions moving forward. But at the same time, as questions come up, we're always limited by the technology, I think. So we're always pushing for advances there.
And are community science-based data sets being used, like iNaturalist and things like that? Because I know that a lot of us input sightings into those kind of things as well. We want to.
Yeah, so we should, it'd be great if Autumn Lynn came at some point, because I think iNaturalist especially is useful for birds. And it's just not an area I'm super familiar with, but definitely lots of groups use citizen science derived information to understand things like departure timing of birds and abundance, linking the movements with the abundance of species, which is really in the end what we really want. Yeah.
Do we have any other questions from the gallery tonight on the movement of life? Okay, no more questions. Thank you so much for coming and sharing this fascinating glimpse into the work that's being done to track animals across the landscape. And we want to be able to tap into the data and help if we can, and keep us posted and come visit us at the museum. And we're going to come visit you at Front Royal.
Yeah, it would be great to keep the conversation going. So thank you so much for the opportunity.
All right, everybody, stay well, stay curious, stay warm, and we'll see you next week as we learn about the more data collection, Chesapeake Bay Sentinel program, and seeing how climate change is affecting sea level rise and marsh habitats in and around this area. So hope to see y'all back next Thursday. Take care, everybody.